In this video I am going to explain you how to design a patch antenna using CST software. So here I am using CST software to design a patch antenna which is fed by a coaxial fed. So the feed which we are using is coaxial type feed. So these are the design parameters. So we are going to design this patch antenna for 2.37 gigahertz. So the length of the patch is 29 mm, width of the patch is 30.5 mm, thickness of the copper which we are taking as 0.035, thickness of the substrate 1.6 mm, length of ground plane is 104 mm, width of ground plane is 104 mm, permittivity of the substrate is 4.4, loss tangent is 0.02, mass density of the substrate is 1900, and the location of the feed point from the center is given, radius of the feed is given, and the radius of the coax is also given. So first let us take a CST and how to do it. You can take a new template, microwave RF optical, take antennas, next planar, next let time domain, and these dimensions how you are going to give gigahertz, etc. And the minimum and maximum frequency. I'm selecting the minimum frequency as 1 gigahertz and maximum as 3 gigahertz. And what are things you have to monitor? So you can monitor everything: far field, power flow, power loss, and you can define some other frequencies also. Like we want to define 2.37. Can add it. Next, finish. So you'll get. So you got the radiation box for the frequency of our interest. So here you can see parameter list. So here we have to use what are the parameters which we are going to do. So here I have the length of the patch, so I am expressing it as L, so it is 29 mm, and width it is 30.5, then the length of the ground plane is 104, width of the ground plane again 104, then thickness of the copper 0.035, thickness of the substrate that is 1.6, so these are the parameters which we are using for designing. So first take modeling. So we have to draw the ground plane first. So for that I am taking this brick, double click, again double click. So you can define it as ground, GROUND, and the minimum is ground plane LG divided by 2, maximum. So the width is, so since we are drawing from the center, we are taking the right hand side as well as the left hand side of that. and Z minimum to Z minimum is 0, Z maximum is thickness of the copper, that is HC, and you can check the material copper and yield and press OK. So you got the ground. Next we have to draw the substrate, brick, double click, double click, double click. So you can name it as substrate, and again the same dimension, so LG by 2, and same LG by 2. Here it is WG by 2, LG by 2. Here the minimum will be HC, maximum will be HC plus HS. And for the material we have to assign new material for that. So epsilon, you can take it as 4.4. Permeability mu, that is 1. Conductivity, take tan delta, take it as 0.02. Then density, you can give it as 1900. You can apply, press OK, and here also you can press it as OK. So substrate is also assigned. Now we have to draw the patch. So again the same brick, double click, double click, double click, and it is patch. So the patch is L by 2, L by 2, the width is W by 2, W by 2, and the minimum is HC plus HS, and the maximum is HC plus HS plus again one HC, the thickness of the substrate. So material here is copper. So okay. Now the patch is also formed. Now to give the feed line, we have to cut this ground plane with a circle. Similarly we have to cut the substrate with another one cylinder so as to make the feed. So for first cutting the ground, we are taking cylinder from this and double click, double click, double click, and define it. So it is something, so we are going to subtract, and here the outer radius 1.6 and the center is 5, Y center is minus 0.5, because this is what we have located the feed. So Z minimum is 0, Z max is HC. We can press OK. Now to subtract it, what you have to do is you can take ground, press ground, boolean, subtract, sub, then press enter, so it will be subtracted. So it is subtracted from the ground plane. Now we have to subtract from the substrate. For that again a cylinder is taken, double click, double click, double click, double click. Now you can define it. So this is feed sub. So here the outer radius is 0.7, so X center is 5, Y center also the same, minus 0.5. Z minimum is HC and Z maximum is HC plus HS. I take this as that material 1. Can press OK. Now can take substrate, boolean, subtract, feed sub. Press enter, so that will also be subtracted from the substrate. And now to draw the feed, we have to take the next cylinder. You can double click. So this is the actual feed which we are drawing. So the outer radius is 0.7. So this is the same 5 and minus 0.5 location of the feed. So the minimum will be minus 5 and the maximum will be HC plus HS plus HC. The material is PEC, that is perfect electric conductor. You can press OK. Now you can see the feed touching the patch from the other side. Now you have to draw the outer covering, and for that you take another cylinder, double click, you can define it as coax. Now the inner radius of this one will be 0.7 and the outer radius will be 1.59. So this is the dielectric part of the coaxial cable between the outer conductor and the inner conductor. So X center is 5, this is minus 0.5, and here minus 5, this place is 0, and the material is vacuum. Okay, you can see it came there. Now you have to define another outer covering for this coaxial cable. For that we are taking cylinder again, double click, defining it, so here the inner radius is 1.59, here it is 1.6, this is 5, this is minus 0.5, this is minus 5, and this is 0. The material here is PEC. And we have got the material like this. So the designing part is over. Now we have to give the feed. So how to give the feed? For that you have to select this face. So you have to use this pick face, and you can double click here, so it will be selected. So go to simulation, take waveguide port, and in that distance to reference plane you can make it as -5. Can press OK. Now the wave port is assigned. So this is the design of the antenna. Now we can go to home, you can save it, you can use simple patch new, any name you can use and you can save it. And now you can start simulation. So it will take some time. So now the simulation is over. So to get the S parameter result, go to this S parameter S11 and you can find the resonance, and to add curve marker, and you can press at this point, and you got it at 2.3686, that is approximately equal to 2.37 gigahertz. We got the matching as minus 16 dB. So this is how to design a patch antenna which is fed by a coaxial cable, or coaxial fed patch antenna. So thanks for watching. Please subscribe my channel for more videos.